Good afternoon, Algebra 2. Today is Red Sox Day. I don't know why, it just is. Red Sox mug. This is for all my Yankee fans out there. I'm trying to think of some kids that are Yankee fans. Connor Godwin, Nolan Madison, Tyler Spiker. I think you might be a Yankee fan. I don't know, but anyways, go Red Sox. So we're on lesson 11. I'm going to talk about radians today. Radians is something that you did discuss in geometry, so what I'm going to show you here should be fairly straightforward. First of all, let's talk about what is radians. Radians are another unit of measure for angles. So it's another way to measure angles. Instead of using degrees, you can use radians. Now, there's more to this. It's another unit of measure for angles that uses the arc length I can spell length, arc length and radius of a circle. So that word right there, radius, is part of radians, which is where it gets its name from. All right, so how does this all work? Well, if you have a circle, I don't know if you remember from geometry or not, but an angle in the center of a circle is called a central angle. If I call that central angle theta right there, our Greek letter, if I label this arc length right here, this distance from here to here, I'm going to call it S. They always use S for arc length in math. I hate S because it looks like a 5, but nothing we can do about it. And then this radius we'll call R for radius. If you want to know the measure of this angle right here, theta, in radians, what you do is you take that angle theta and you take the arc length and divide it by the radius. And that formula right there should look familiar. Theta equals S over R. That's something that you do and you talk about in geometry. So radians are a unit of measure to measure angles, and they're based off of this arc length and the radius of the circle. So now I just want to show you a couple quick questions on how you use this theta equals S over R formula, and then we'll get into some more of the trigonometry stuff that we've been doing and switch it to radians. Okay, so here's our first example here. Here's a circle drawn. We have a central angle, theta. This arc length right here is a distance of 9. I didn't put units on here. It could be 9 inches, 9 feet, whatever the units are. And then we have a radius of 4. So if I want to know the measure of this angle right here in radians, I'm going to use my theta equals S over R formula. And theta is going to be my arc length, S, which is 9, over my radius, 4. So 9 divided by 4, I find out that theta is 2.25 radians. Remember, we're not in degrees anymore, we're in radians. That probably doesn't mean a whole lot to you, like 2.25 radians. What does that even look like? I'm going to teach you how to convert from radians to degrees shortly, so you can get an idea of what a radian actually looks like. See, when we're doing weather, we all know that what Fahrenheit is for the most part. I mean, we know that if it's 50 degrees Fahrenheit out, how I should dress to go outside. But if I tell you it's 37 degrees Celsius outside, if you're not taking science or haven't taken science in a while, you may not know what Celsius means as far as 37 degrees, but you can convert that. There's a formula to switch from Celsius to Fahrenheit, and then it would be something you understand. There's a formula to switch from radians to degrees, and I'm going to show you that here in a second so that we can talk about how to switch things that are in radians to degrees. So what's the connection between radians and degrees? Well, here's the connection. For every pi radians, there is 180 degrees. That's the conversion between the two. Pi radians, we all know pi, 3.14, yada, yada, yada. If you take that many radians, it's going to equal 180 degrees. So now what we're going to talk about is how you take angles that are in radian measure and switch them back to degrees. Now, in trig, most of our degree measures that we get in radians are going to have a pi in them. All right, they're going to be pi over this or pi over that. So you're going to see pi. So these are all going to come out nice and even for us. There are other times when they don't, but we're going to keep things simplistic and make it easy for you here. So let's do a quick example. What if I told you an angle was pi over 9 radians? Great. What does that mean as far as degrees go? Well, since there are pi radians for every 180 degrees, what we do is we take this pi over 9 and we multiply it by the fact that there's 180 degrees for every pi radian. So we multiply by 180 over pi. And this, I believe, is something that you did in geometry. So what does that do for us? Well, that makes the pi, since they're diagonal to each other, cancel out, cross out, reduce. And then I can divide 9 into 9 once, and 9 goes into 180 20 times. So I figured out that we're talking about a 20-degree angle right here. Another example, I have 2 pi over 5 this time. All right, show you what it looks like when there's a number next to the pi up on top. So again, since there's pi radians for every 180 degrees, I'm going to multiply by 180 over pi so that I can get this thing to be in degrees. My pi's will reduce out. So now from here, I can do a couple of things. I could multiply the 2 and the 180 together to get 360 and then divide it by 5. Or I could do some reducing first. All right, figure out how many times 5 goes into 180 and reduce from there. So you have a lot of options on how you want to do that. So if I want to figure out, I'll just reduce the 5 and 180. 5 goes into 5 and 1. So how many times does 5 go into 180? Let's see, 3, 15, looks like 36 times. So that's going to turn into a 36. And then just multiply what's left over. 2 times 36. This is 72 degrees. So 2 pi over 5 is 72 degrees. All right, let's do one more. All right, last one here, 3 pi over 2. This is going to come out to be an angle that you should be familiar with. 3 pi over 2, I'm going to multiply by 180 over pi. Again, my pi's will cancel. I can do some reducing here. 2 goes into 2 once. It goes into 180 90 times. 90 times 3 is 270 degrees. I told you that'd be an angle that you're familiar with. One of the ones we've been working with. All right, so that's just a brief introduction, or reminder, I should say, because a lot of this is stuff from geometry, on what radians are and how we take something that's in radian measure and switch it to degrees. All right. Now, last thing. Remember that first question we did where we got 2.25 radians for an answer? That doesn't have pi in it. All right, so how would that work when you multiply, or when you convert it to degrees? You're still going to multiply it by 180 over pi. The problem is there's no pi's to reduce out. So in this case, we'd actually have to multiply 2.25 times 180 and divide it by pi. All right, that's going to be calculator work. Let's do that real quick. 2.25 times 180. And then I'm going to divide that by pi using the pi button on my calculator. So there's my work on my screen here. And I get that, which is not a very nice answer. But you can see that it's about, when you round, about 129 degrees. So this is approximately 129 degrees. We know what 129 degrees looks like. We weren't sure what 2.25 radians was until we converted it to degrees. All right, so that's just an example of converting something to degrees that doesn't have a pi in it. It comes out as nice. All right, let me know how you make out on the homework. Email me if you have questions.